All right, 6.1, confidence intervals. So we're going to talk about what a confidence interval is. I'm going to teach you how to find some critical z-scores, and then we're going to find margin of error. We'll save this for tomorrow, how to make a confidence interval. It's pretty good stuff here. So pretend, let's do question number 1 here. Pretend we're going to find, we're interested in finding the average ACT score at Verne Hills High School, right? So the average ACT score for the whole high school. So here, the average ACT score for the whole high school is going to be mu, or my mean of the total average. Now that's going to be pretty tough for us to do because it would just take a long time. So what we want to do is we want to take a sample and find that mean. So this is mu goes with the population. And the sample mean, let's say I just look at a class, let's say, and I find the average there, that's going to be the standard, or sorry, the mean of the sample. We call that the sample. So that's known as X bar, right? So the whole school, their average ACT score is mu, and our classes is X bar. Now, what we can do is we can make a curve, and we could say, okay, put our sample in the middle, and what we do is we make kind of a high and a low of where we think the actual mean falls in relation to our X bar. So let's say I have a pretty average class, right? Maybe my mean is identical to my X bar, but the mean can be over here. The actual mean of the population could be higher than my sample, or it could be lower than my sample, or it could be even higher than my sample, or it could be equal to my sample, right? So we're going to try to use our sample mean to estimate the population mean. Okay, so there you go. Mu stands for the population mean, and X bar stands for the sample mean. And what we're going to do is we're going to take a sample, and we're going to have the sample be the center of my curve, and what we're going to do is we're going to find a high post and a low post that's kind of an acceptable area for the population to be in, right? So those are called confidence intervals. So if I'm really confident, if I want to make a really big confidence interval, I'd make a 100% confidence interval, right? But that's not going to happen very often. Typically, the confidence intervals you're going to see are 99%, which is pretty wide. And then we can narrow it up a little bit, and we can go at 95%. And then we can go even narrower, and we can make a 90% confidence interval. So the lower my confidence, that means the lower you are sure that the mean is actually in here, right? So if I take my confidence interval and I make it 90%, meaning the middle is going to be 90% here, that means that I have 10% in the tails. So the actual mean could be over here, and it could be over here. I'm not really sure with my 90%. If I make the middle 95%, now I only have 5% in the tails, right? And even if I go even bigger and I make it even more confident, 99%, right, then I only have 1% or 0.5 in the tails. So the higher your confidence level is, the more confident you are that the actual mean is in that region, right? The lower your confidence level is, the less confident you are that the mean's actually in this region because it's narrower, right? So an 86% confidence interval is going to be even smaller than this one, and a 70% confidence interval is going to be even smaller than that one, right? So in order to find these confidence intervals, what I need to do is I need to find, we call it ZC, or Z critical, right? So all of these are going to have a critical Z score. And think about it, I'm going from a percentage, the middle 90%, the middle 95%, the middle 99%, to a Z score. So I'm going to use invert norms. So the way I would do this is I would say, well, I have 90% here, which means I have 10% left in each tail, distributed evenly. So that means I have 5% here, and I have 5% here, right? So I'll just show you with the old calculator. I would type in invert norm, and I would type in 0.05, because that'll give me this Z-score. So invert norm 0.05. Let's do that with the calculator real quick. Second distribution, invert norm 0.05 left. So negative 1 point. So Z here, the Z critical is going to be negative 1.64 and positive 1.64. It's going to give you two of them, a low and a high, right? Let's do it again for this one. So this is going to be invert norm. And now 95%, so that means that we have 5% in the two tails, this tail and this tail. So that means I have 2.5%, 0.025 here, and 0.025 over here. So I go invert norm, 0.025, second distribution, invert norm, 0.025, and that's going to give me 0.025, let's see here. Oh, you know what? Second distribution, invert norm, 0.025 left, boom, negative 1.95. So Z critical here is going to be negative 1.95, and it's also going to be positive 1.95 on the other side of the mean, right? 99%, so think about it. That means I have 1%, 0.01 between here and here, so that's going to be 0.005 and 0.005. You do 0.01 divided by 2. So I go invert norm, 0.005, mean 0, standard deviation 1, tail going to the left, and I get negative. So Z critical here is going to be negative 2.57 and positive 2.57. Okay, so go ahead and pause the video real quick. Try to figure out what the middle 86% is and what the middle 70% is. Go ahead. What your Z critical is. Okay, so remember 0 goes in the middle, right? We're trying to figure out 86%, so that's going to be the middle 86%. So if I do 1 minus 0.86, I'll get 0.14. So I know I have 14% in this tail and this tail, which means I have 0.07 in this tail and 0.07 in this tail. So I'm going to go invert norm, 0.07. And that's going to get me my critical Z's, right? So invert norm, 0.07. Boom. Negative 1 point plus or minus 1.475. So that's going to be negative 1.475 here for the Z score and positive 1.475 for this one. Middle 70%. So again, that's going to be the middle 70%, which means I have 30% in these two tails, which means I have 0.15 over here and 0.15 over here. So I'm going to go invert norm, 0.15, see what I get. Invert norm, 0.15 this time. Mean 0, standard deviation 1, so I get negative 1.036. So those are my Z criticals, and it's going to be negative 1.036 over here and positive 1.036 over there. Okay? Cool. So the next thing we have to talk about, we figure out how to find those critical Z's. We're just kind of building our way up to this confidence interval, which we'll do on Tuesday. Let's talk about margin of error. So margin of error is the distance that the gate is between your critical Z score and the center, right? So if the margin of error is going to be going from here to here, so it's kind of that distance between what we got as a mean and the tallest and shortest, or the biggest and smallest acceptable mean of the population that we can get, right? And the way we do that is we take our Z critical, right, which is the number of standard deviations away, and we multiply by the standard deviation, right? So we have to kind of combine this with what we learned last week. And remember, we're talking about means, so the standard deviation is going to be equal to our sample standard deviation divided by the square root of our sample size. Okay, so let's find the margin of error for this example, and then you can try this example here. So we're doing a 90% confidence interval, so that means that I need the middle 90%. And I have a standard deviation of 25. And I have a sample size of 100. So if I want to figure out what my mean sample is, I go ahead and I divide this by the square root of 100. right? So I have to figure out what these z's are, figure out what this z is, this z critical, and then I multiply it because that's the number of standard deviations away from the mean I am. I multiply it by the standard deviation, and that'll be kind of the ruler going from the middle to that point. So first thing we need to do is find our critical z value. So we go invert norm. And we have the middle 90%, so that means I have 10% here. And here divided evenly, so that's going to be 0.05 or 5%. So I do 0.05. You have the new calculator, you can do it a little differently, but we'll just leave it like that. So I get my critical z to be equal to negative 1.644. Now all I need to do is take that negative 1.644, that's the number of standard deviations away from the mean I am, and I multiply by my standard deviation, 25 divided by the square root of 100. So if I take that, second answer, times 25 divided by the square root of 100, or the standard deviation, that will give me negative 4.1. So we just found the margin of error. So that means, let's say the mean is 0, I can go up to 4.1, or I can go down to negative 4.1, and that's going to be an acceptable area for the actual mean to be in, right? Cool, go ahead and pause the video, you guys can try this one real quick. So again, we don't know what the mean is, we're going to figure that out tomorrow. I'll have to give it to you, but we're looking for the middle 95%, so 0.95. So again, what we need to do is we need to find that z-score, that critical z, so we start off at just 0, or we can call it x bar, and we're trying to figure out how far up and how far down I can go in order to get acceptable means. Okay, so the way you do that is you just take, 0.95, go invert norm, second distribution, invert norm. 95%, which means I have 5% in the tail, so I have 0.025 over here and 0.025 over there, so 0.025. Mean 0, standard deviation 1, go ahead, let's find out. So we got we got a z critical of 1.96. So that's how many standard deviations away this fence post is. I just take that and I multiply by the standard deviation itself. So the standard deviation is 1.96 is our critical z, times the standard deviation is 10, divided by the square root of 250. So if I take second answer, times 10 divided by the square root of 250, in parentheses, I'll get negative 1.24. So that means I can go here 1.24, and I can go this way negative 1.24, right? And those are going to be my acceptable ranges of my population mean, right? So big picture stuff, what you do is you take a sample, you find the mean of that sample, right? The mean of that sample, we call it an x bar. And then what you do is you build a gate around that. And it can be a 90% gate, or it could be a 95, or a 99, or a 99.7. It all depends on how sure you want to be that the real mean is somewhere in here. So the mean could be lower, the real mean could be higher. Our goal is to figure out the range of real means that this can be in. Okay, that's it.